People have been placing ideas and things into categories throughout history and across cultures. This type of grouping seems to be a natural part of how we think and process the world around us. Weather uses categories to group storms by intensity, letting us know how the danger they present. People born at different times are categorized into different generations because individuals growing up at different times might display similar behaviors. Our finances are categorized based on the types of things that we spend our money on as a way to identify places where we can save some of that money. In the sciences, we also categorize things for similar reasons. We call this process classification. By classifying the things we research into these categories, we are often able to more easily understand the group as a whole, as well as to better see the patterns in things that might be otherwise very different from one another. In this video, we will classify all forms of matter into one of 4 different categories. My name is Peter Kiefer. Let's learn some chemistry. In this video, we'll discuss everything that you need to know in order to classify matter into one of the 4 categories we'll define in just a moment. We'll begin this process by defining what classification of matter really is, as well as providing some other examples of classification systems you might already be familiar with. We're going to learn how to identify matter as either being homogeneous or heterogeneous. This will be a major component in some of the bigger classification we do at the end of the video. And then finally, we'll talk about how to actually classify any sample of matter that you might see in the classroom into one of the 4 main categories. I'll also introduce a classification tool, a flowchart, to help you figure this process out. Altogether, this is generally not a topic students tend to struggle with just a little bit of time and practice. I think this is something you will ultimately find very simple. Let's start this process by defining what classification is. Classification is the process of grouping a large number of things or ideas into smaller, separate categories. This process helps us to organize large, complex system of information into smaller things that we can better keep track of, and it also helps us to identify patterns in those large groups of things. Those patterns are things we might not normally have been able to see without the classification process that we went through. As a couple of examples of places where you might already be familiar, the Dewey Decimal System, how libraries are organized. We have a diagram on the right, classifies different categories of books into different topics like general knowledge, religion, and languages. In biology courses, you learned how to classify organisms into different groups or taxonomy. This is when we talked about things like kingdoms and phylums and classes, a very complex system with literally thousands and thousands of entries. In the medical world, different types of diseases or injuries are classified into different groups, allowing doctors to use one set of skills that might potentially apply to lots and lots of different applications. Our classification method is going to serve exactly the same purpose as these. It's just going to apply very specifically to different types of matter. Classification begins with the understanding of the concept of homogeneity. Homogeneity is whether or not matter is made up of all the same substance, or if it has the separate, distinct ingredients that can still be seen individually. You can almost imagine this as how well something is mixed together. Some things will mix together completely, other combinations will not. Matter that is considered homogeneous is a material that is made all the same throughout. This is made of either a single pure substance, in which place it's all identical, or it's a combination of many ingredients that combine together completely. And that's going to be the major distinction we make with the other category. If something is not homogeneous, then it must be heterogeneous. This is a material made up of many separate ingredients that do not combine together well. You can still see those separate ingredients regardless of how often or how much you try and mix them together. Being able to define matter as being either homogeneous or heterogeneous, as I said earlier, is going to be the part of the bigger classification process that we do, so it's something you definitely need to be familiar with, and you'll certainly see practice to go along with this. A simple test you can think in your mind of this is if I were to take a spoonful sample of my matter, would every different spoonful I take look exactly the same as every other spoonful? If all those spoonfuls are going to be the same, your matter is homogeneous. If each spoonful is going to look different than one another, you must be dealing with matter that is heterogeneous. So we've been leading up to this throughout the entire video. What are these categories that we are going to be working with in terms of our classification of matter? Our first category is a solution. A solution is first of all made of two or more ingredients. There has to be at least two things, and they combine to make a new homogeneous substance. Remember, homogeneous meaning all the parts of the solution are the same. A great example of this would be something like sugar water. When the sugar and the water are stirred together, they combine in a way that we can no longer see the sugar and water separate from one another. As a contrast to a solution, we also have a mixture. A mixture is also made of two or more ingredients that combine to make a heterogeneous substance, meaning again, no matter how much we stir or combine, we would still expect to see those separate parts. We could take sand and water and mix them together, and we know that no matter how much we stir, we'll still see the sand eventually sinking down to the bottom of that container that the water is in. Elements are an example of a pure substance. In this case, these elements are only made from one particular type of atom, and all atoms in that element sample are identical to one another. Later in the year, we'll identify the fact that that is not entirely true, but for where we are now, it makes a lot of sense. Finally, our last category is compound. This is also a pure substance and a bit of a tricky concept. It is made of two or more different atoms that are specifically chemically bonded to one another. This is what separates a compound from a mixture. When those atoms bond together with one another, they behave collectively as a group, and the result is we get a substance we still consider pure. Water is a great example of a compound. It's made of both hydrogen atoms and oxygen atoms, but when they behave together as a group, they create the new substance we know as water. Your job will be to take a sample of matter, take some information about that matter, and decide which of these four categories that matter most likely fits into. One way of solving this problem is simply using these definitions. Many students, not all, but many, are capable of simply using this and saying, oh, this must be a mixture, oh, this must be an element. For some of you, however, some simple definitions might not be enough to get the job done, to classify matter into our four categories. And for many of you, in the very beginning, we might need a little bit more support to figure this out. I've created this flowchart, which is available via my website, that gives you a decision-making process. You can follow along with the chart that ultimately lands at one of the four categories. We can see those four categories at the bottom of the flowchart highlighted in purple, along with their definitions down below. The way we use this flowchart is very, very simple. We begin up here at the top of the flowchart where we have all different types of matter. And then down below, we see that in red, there's a series of questions that we can ask along with the possible answers of those questions. By asking these questions, it's going to direct us on a particular path down the flowchart, ultimately leading us to one of our possible answers. For example, in this case, a heterogeneous mixture. If you can take the sample you're looking at and answer these questions one at a time, classification should be pretty quick and easy. The more and more of these you do on your own, the more likely you'll be able to answer these questions without the help of the flowchart. I can explain this process all I want, but the easiest way to see how this works is simply by going through a series of examples. I've got 4 examples there on the left. We'll try and use the flowchart to class each one of these. We'll do the first 2 a little bit more slowly, and then we'll speed things up as we go along. We'll start our list of examples here by discussing a salad. I like to choose examples that people will generally be very familiar with. As before, we'll start up here at the top where we have all different types of matter. And our first question asks us, is our sample made up of one ingredient or many? When you think of a salad, it's got lettuce, it's got tomatoes, it's got dressing, cucumbers, whatever you decide to put in the salad, the answer to that question is clearly that a salad is made up of many ingredients, leading us to the fact that this must be some type of mixture. Now that we know that we're dealing with a mixture, we go here to our second question. Is the mixture homogeneous? If it is, that would mean every single part of the salad looks identical to every other part of the salad. No salad looks like that. Your salad's got lettuce and tomatoes and all those different ingredients. The clear answer here is that no, my salad has all different parts, meaning my salad must be a heterogeneous mixture, or you could simply use the word mixture. Let's repeat this process with another example, in this case, salt water. Again, we start at the top of the flow chart here and we ask, is our sample made up of one ingredient or many? Well, the word we describe answers that question. Salt water is made up of two ingredients, salt and water. So again, we choose the many ingredients path. That tells us that salt water is yet another type of mixture. Is this mixture homogeneous? When salt and water combine, the salt and the water dissolve into one another, meaning that all parts look the same. Every spoonful of salt water looks the same as every other spoonful. This substance is homogeneous, which means now we're dealing with a homogeneous mixture, which we often refer to as a solution. Let's do our next couple examples a little bit faster. We'll discuss water first. Again, we go to our question, is it made of one ingredient or many? Water is just made of one thing, water. So we would say in this case, it is a one ingredient component. The description should always provide you with enough information. That means water is a type of pure substance, unlike a mixture. Now, we have to ask ourselves a different question. Does this substance appear on the periodic table? Well, the only thing that does appear on the periodic table are elements, and water is nowhere to be found on the periodic table. If you decide it's not on the periodic table, the only choice we have then is that water must be some type of compound. Last but not least, we have sodium. Again, the description implies that the only ingredient is the sodium thing that's here. That means one ingredient, which again means we're dealing with a pure substance. Can you find it on the periodic table? In this case, the answer to that question is yes, meaning we follow the path down here, and sodium must be a type of element. If you've been following along, what I can hope you see is that each of these small questions is a very, very simple question to answer, and it takes the more complex process of classification and breaks it down into a couple easier steps. As I mentioned before, the more and more of this you practice, especially with the flowchart, the easier it's going to become, and you'll be able to do these classifications without this type of assistance, which is where I need you guys eventually to be. And that's pretty much it, ladies and gentlemen. At this point in time, you should be able to do a couple different things. First of all, you should be able to identify a sample as being either homogeneous or heterogeneous based on the definitions we identified. And you should now be able to classify matter into our four main categories: a solution, a mixture, an element, or a compound. Again, I think that flow chart is pretty key in the beginning, especially if you feel like you're having trouble with the topic, but I think within a very short amount of time and practice, you should definitely be able to wean yourself off of it. As always, I'd like to thank you guys for taking the time to follow along with me as we discuss classification of matter. If you found this video helpful, please check out my YouTube channel to get more videos on other science topics, as well as my course website where I host lots of practice problems, reference documents, and all the things I mentioned in the video itself.